today we are going to start compound inequalities. And there are two types of compound inequalities we can talk about. Compound and compound or, where and or are kind of being used as an adjective to describe the type of compound inequality it is. Okay, so in the English vocabulary, what does the word compound mean? Right? We're putting multiple things together. So that's exactly what's happening here. We are going to have two inequalities happening at the same time. And those two inequalities are going to be attached with either the word and or the word or. Okay, so this is the harder math piece to think about. I don't even know, this is the harder English piece to think about. What does the word or mean? Right, so this one or another one, an option, but that still uses the word or in it. So if we have an option, what are we doing with our options? DJ, I don't know about compare. I mean, we could be doing some comparing, but there's probably a better descriptor we can use in here. Mitch? If I say you have an option of, I always use Coke or Pepsi because I love Coke. If you have an option of Coke or Pepsi, what's happening?
You're deciding which one you want.
You're picking one. Okay, so or means that we have a choice. Okay, and you get one. This is not Webster Dictionary definition. I have no idea what Webster Dictionary says, but this is our definition for what we're doing, okay? So same idea, what does and mean?
You get both.
Right? You have a choice, you have options, and you can get both. Okay, so there's still like those two ideas happening, but you get both. Right? You get Coke and Pepsi. Maybe options would be a better word here than choice, but you know what I mean. So today we're going to be looking at compound inequalities, and it's not going to be Coke or Pepsi, but it'll be one inequality or the other inequality. Okay, it'll be one inequality and the other inequality. Okay? So maybe we have something like x is greater than 4 or x is less than or equal to 2. This whole entire thing together is one compound inequality. And maybe this is a situation which I have to kind of keep things very lame-o and simplify. Okay, but maybe this is a situation where we know that a business will be profitable if one thing happens or if another thing happens. Okay, but everything else isn't going to be profitable to us. Okay, so we get one option or we get the other option. We're obviously looking at a very simplistic standpoint, but that's sort of the idea behind it. So we have talked about the fact before that inequalities in any way, shape, or form have how many answers? If I say x is greater than 2, how many solutions is that? Infinitely many. So compound inequalities are no different. We still have infinitely many solutions. And you don't want the homework assignment to go home and write down all of the possible answers, right? Because how long is that going to take you?
Forever.
For forever, so definitely don't want that one. So instead of writing them all down, what do we do instead? I mean, we can just write an inequality sign, absolutely, but what was our other option?
Something.
Not words that we wrote down, but a representation we gave. Like you just did it on your quiz.
Number line?
Right? We graphed them on a number line and we represented what all of those solutions look like. So we want to be able to do the same thing today with compound inequalities. Okay. So same idea is true today, that we're going to make a number line to represent it. Okay, for a compound inequality, you only need to have 2 numbers on the number line. Because if we had to evenly space numbers in between -47 and 102, and that would be a ginormous number line, right? So you just need to make sure you're getting the smaller number on the left and the larger number on the right. So hopefully we realize that 2 is smaller, so it's going on the left, and 4 is larger, so it's going on the right. And here is where I need you to trust me for a moment and to not decide that it's just stupid and you're not going to do it. Because on this first example, it seems stupid. In the long run, it makes sense. Right? So when we go to graph a compound inequality, we are going to graph these as if they are 2 individual ones above the number line. Not on the number line, but above it. We're going to graph it above and then interpret what it means. Okay, so we're going to graph this just like we have been. So open or filled in circle at 4. Open. Are we going to shade to the right or are we going to shade to the left? Okay, because those are the normal graphing rules we've been doing. Okay, then open or filled in at 2. Closed. And to the right or to the left? Questions on where any of this stuff above came from? So I'm getting a little bit old, and I'm struggling with great games that you guys would think about, but Tetris is always the one that comes to brain for me. But think about these as if they're pieces that are falling down. Okay, and they're falling down until they hit the ground here. Okay. We want to copy anything onto our final graph where we are getting one of them. Anywhere that we get 1 counts as an answer. Why? Because that's what or means. Okay, so if these were to fall down on the number line, would this area of the number line get hit? I'm saying heads nod yes, but some of you looking at me like a deer in headlight. Do you understand what I'm asking? Can I at least get, no, we don't understand what I'm asking. Okay, so think about this maybe as,
Fortnite.
I don't know how to think about this as Fortnite.
We're knocking down a structure.
The scars.
There was something, I'm trying to think
Fix it, Felix.
Fix it.
Hubert.
Okay, so maybe think about this as the idea of if you could lift this blue line up. Okay, so if you can lift this blue line up, where would it touch stuff above it? Okay, so if I'm pushing this blue line up, do you agree that here in the middle I'm not going to touch any graph area? So it doesn't count. But do you agree that if I lift up over here, it's going to run into this?
Yeah.
So this gets copied down onto the number line because I touched in one place. So because I touched in one place, this gets copied down onto the number line. Anywhere else I'm going to touch in one place. Over here, right? If I lift up over here, it's going to touch in one place. So this gets copied down onto the number line as well. And that's our final answer. And my students are like, well, why in the world did you graph above? Because that's exactly the same thing. So you just have to bear in mind with me. Like, just trust me for a moment. Okay? So this graph right here represents the compound inequality of x being greater than 4 or x being less than or equal to 2. Okay, maybe we're given this compound inequality. What number am I going to put over here?
-6.
-6. And what number am I going to put here?
-1.
-1. I'm just simply putting the smaller number on the left, and negatives kind of work backwards, right? Open or filled in at -6.
Open.
Guys in the back, we need to get it together. Some of you are going to be sitting up here by me. Are we shading to the right or to the left? Notice how I'm making that line all the way across the number line. Don't just make it really short, all the way across. Opener fills in at -1. Which way am I shading? Okay, now remember, with compound or, I want to put anything on the number line where it is happening at least one time, where I'm getting 1. So am I getting 1 over here? Nope. Am I getting 1 here in the middle? Yep. Am I getting 1 over here? Yep. In fact, I'm getting both as a choice, but at least one of them. So my final answer on this one is going to be this.
With a filled-in circle, right?
Do I need to, that was the next thing I was exactly going to say. Do I need to write a filled-in circle here?
No.
Okay, so I'm hearing some yeses and some nos.
No,
Those of you say no, why not? Mitch?
because that's already going, like shading, like if it's on -1 and it's closed, that graph alone, that is saying it can be -1.
Do we agree that this shading right here is saying already that it can be -1?
Yeah.
So filling in another filled-in circle there isn't going to tell us any more information that we don't already have.
Yeah, it could.
Okay?
Is it equal to though? Because that one's equal to.
It does say or equal to, but this one already makes it or equal to. Right? This includes -1 as an answer. That or equal to says -1 is an answer. And this is still saying -1 is an answer. Yes,
So
sir.
what if it said x is greater than -1?
Okay, so that's an excellent question. What happens if instead, you don't need to write this down, I'm just going to edit so we can discuss. What happens if instead it said this, and so instead right here, we have this? Would we need to fill an open circle at -1?
No.
Really
Yeah,
think.
I haven't defined
Yes,
yet.
because it can't be 1. -1.
It can't? Can it be -1 on this line now?
Oh, yeah.
Yes, right? So it can't be -1 according to the pink, but we're copying down anywhere that it's just one of them. And is -1 on one of them? Yep, it's on the green one, and so we still just shade over it. The only point that the opener filled in circles count is at the start or the end of a line. Okay? Are we okay on that one? Okay, how about this one? I'm just saying, right? I just didn't want you to sit there and be miserable.
Yeah,
Okay? What do we think about this one? Any thoughts on what we might want to do first? Solve them. Right? This isn't like anything we haven't done. Just treat it as if it's two separate inequalities and solve it like normal. So we're start solving. Oh, you can have something. Okay, so over here I'm going to get x is greater than -7. What am I going to get over here?
X is less than or equal to -2.
X is less than or equal to -2 because, I mean, it's a compound inequality, but my rules don't change. I divided by a negative, so I got to flip the inequality sign. Okay, which one's going to go on the left? Opener filled in at -7. To the right or to the left? To the right or to the left? Okay, compound or, we want anywhere that we get 1. Are we going to get one over here? Are we going to get one in the middle? Are we going to get one over here?
Yep.
Is there any place we don't get one of them?
Nope.
So what do we think our answer is?
All real numbers.
All real numbers? Right? This ends up being our entire number line. It is all real numbers. Now, sometimes my students will say, well, Mrs. McKinney, I don't think I really need to do that graphing above. I think I can interpret that without doing the graphing above. Possibly. I'm not going to grade what you graph above. However, this little catch now happens. Because what happens if now I have something that says, x is greater than 5, and x is less than or equal to 10.
You get both.
I'm still going to make a number line with the same rules. So I'm still going to put the smaller number on the left. I'm still going to graph them both individually up above. Bless you. Okay, and the last problem, we just saw something that was almost exactly the same, and we wrote down all real numbers. Okay, but this is definitely not in all real numbers because of one simple word change. Right? It now says and. And what did and mean? We need both of them. So now we're looking for where we get both of them. Do we get both of them over here?
No.
Both of them in the middle?
Yeah.
Both of them over here?
No.
So the only place we are getting both is here. And so this is what our final answer looks like.
Yes.
Okay, so not only can we have stuff above that looks exactly the same, we have to interpret it differently based on this one word that we see. And if that wasn't complicated enough, sometimes the word and doesn't show up at all. Okay, because sometimes we will see something written this way. And this is the most common way that we see a compound inequality written. Okay, where it's actually kind of squished together. Okay, if we see the word or, we can be certain it is a compound or. If we see the word and, we can be certain it is a compound and. If we do not see either, then it is a compound and. I mean, that should make sense with our English vocabulary. Right? If we have two things that are going together, it makes sense that we could write them in one thing. Okay, so if we want to take this and we want to graph this, we are going to have to think very carefully here. Okay, so smaller number is still on the left, no problem there. This is going to be the easier one to graph. Open or filled in at 11?
Filled in.
Filled in to the right or to the left? Open or filled in at 6?
Filled in.
To the right or to the left? So I'm hearing some lefts and some rights. What do we
To
think?
the right.
Why to the right?
flip this on to get x.
Right? Because if I'm just looking right here, that doesn't have the x first. And so this really truly would be x is greater than or equal to 6. When I rewrite with the variable first, that's a reason to flip the sign, and so my shading is going this way. And so what counts as part of my final answer? This stuff where I see both of them, which is the stuff in the middle. How are we doing so far? Far so good? Ah. Thoughts on what we should do first here? Do we think we can go straight to graphing this? Why not? Yeah, there's not just that variable. We've got that -4 and 2 floating around with the x. So when we see that, that typically thinks, okay, we need to solve. The problem is that then most of us are going, okay, how am I going to solve this? Right, what am I going to do with this? There are multiple ways that we can solve this. And often students who have seen this in middle school come to me and say, can I split this into 2 separate equations, inequalities? And my answer to that is yes, but you're going to make a lot of extra work for yourself. Okay, it really honestly is just as easy to solve it in one chunk as long as you know what you need to do. Okay, and my suggestion is to cover up until you get past that first inequality. And if I cover up here, what would we do first to solve this? Add 4, right? And whatever I do to one side, I have to do to the other. But now how many sides do we have? So whatever we do to one side, we have to do to the others. And we need that to happen in all 3 places. Okay, so 8 plus 4 is? What are we going to do next? Now, are we okay with dividing by 2? Open or filled in at 13? Open or filled in at 6?
Filled in.
Which way am I shading here?
Left, sorry.
What's my answer going to be? No solution? Because there's nowhere we get both of them. This is a no solution.